Okay, welcome to this it should be a very quick video on how, it's almost purely a math topic for this one. And this isn't something that will be asked directly on the Regents exam. This is just some math that I want to go over before we get to our final topic in forces, which is forces that act on an object on a ramp. It'll be the most complex topic in forces that we do in this year. That's why I want to spend a little bit more time going over it, and that's why I want to spend some time going over the requisite math. I've got a picture of a triangle here, and what I want you to do is I want to determine the measure of angles A through F for the drawing below. If you look here, it's not a perfect drawing. This is supposed to be a right angle, but it probably looks a little lopsided to you. But just imagine that this is a perfect right angle. These other ones are perfect. This is what we're trying to do here is we want to figure out the measure of angles A, B, C, D, E, and F using nothing more than math. We're not going to measure these angles with a protractor. We're going to use math to figure out what they are. What we're told is that we have right angles here, here, and here, and we have a 24-degree angle down here. So I would start, the easiest one, and the one you kind of have to start with, is starting with A. I suppose you could start with C as well. For A, let's use some facts that we remember from geometry. This angle right down here, 24 degrees, is interesting because that's the angle that's usually given to you in ramp problems. I've got this mini triangle right here, which is kind of interesting. Okay, I've got this mini triangle right here, and I'll notice that I have a right angle here. This is an angle of 24 degrees, and then I have this angle A up here that I don't know yet. One of the rules for triangles is that the sum, and you should have learned this in math, the sum of all of the angles in a triangle must add up to a certain number, and that certain number is 180 degrees. So if I'm looking to solve for A, well, this angle's 24, this angle's 90, angle A is what I don't know. I know the sum of all of those has to equal 180 degrees. So if I want to find A, all I have to do is subtract these to the other side. Do 180 minus 90 minus 24. 180 minus 90 minus 24. A must be 66 degrees. Okay, so A is 66 degrees. That's important. I would probably try and find angle B next. And this takes a little bit of reasoning. If I know that this angle right here is 90 degrees, then I know that the angle from here all the way across to here, I know that's got to be 180 degrees. That's called supplementary. So actually, I haven't gotten there yet. This whole angle is 180 degrees from one side of this vertex to the other. That's 180 degrees. This whole angle is made up of the right angle plus angle A plus angle B. The sum of all of those angles has to be 180 degrees. This is called supplementary angles, when angles add up to 180 degrees. So what I would write is A plus B plus the 90-degree angle must equal 180 degrees due to being supplementary. So that means we can do A plus B plus 90 degrees equals 180 degrees. I just found that A was 66 degrees plus B plus 90 equals 180 degrees. So what I'm going to do is I'm going to take 180, and just like last time, I'm going to subtract 90 to the other side. 180 minus 90 is 90. Now I'm going to subtract 66 to the other side, and notice this, we get 24 degrees. Where have we seen 24 degrees before? We saw it right down in the angle we were initially given. That's the most important thing that I want to show you here, but we're going to keep going and finding C, D, E, and F. It turns out that this angle right here is the most important angle that you need to be able to find, and you'll see why that is when we go and do our actual notes on ramps. But for now, let's continue on. Okay, so C, let's see. I know the angle from here over to here has to be 180 degrees. So C plus, this is a right angle, 90 degrees, must equal 180 degrees because of supplementary angles. Let me just put a note here. Angles in a triangle add to 180 degrees. 180 minus 90 is 90 degrees. C must be a 90-degree angle. The whole thing is 180, but if this is already 90, this also has to be 90. D, through the same logic as A, I have a triangle with a 24-degree angle, a 90-degree angle, and an unknown angle. D must be 66 degrees. Running out of room here a little bit. E, if you look at the big triangle right here, this big triangle has the same exact measurements as this littler triangle. Okay, it's the same exact thing. Matter of fact, they're similar triangles because they have all these same angles. Okay, 24-degree angle down here, right angle, 66. 24-degree angle, right angle. E must be 66. Same as A and D. I'm going to put F down here. For F, there's a number of ways we could do this. We could use the quadrilateral rule, where the sum of the interior angles in a quadrilateral must equal 360 degrees, 90, 90, and we know this is 66. But I'm not going to use that. I'm going to say that this must be, the D and F are supplementary. So since D we found out is 66 plus F equals 180 degrees, this means F must be 180 minus 66, 114 degrees. Okay? Again, in the study of physics, it is most important that you know how to find angle B. It's most important that you recognize that the angle that we were given at the beginning of the problem will also show up where angle B is. Okay, it's important that this angle, 24 degrees, and this angle is 24 degrees, and that you recognize that. Understanding how to find this angle will be extremely helpful when we study objects that are placed on ramps. That's all I'm going to actually do for this video. We are going to do the forces on a ramp video next, but I'm going to separate out those videos. Okay, so nice quick one. I'll talk to you later.